As part of a population study, the State Department of Fish and Wildlife counts the fish in one section of the Huron River each fall. In 1995, the fish count was 1,200. From 1995 to 1998, the average annual growth rate was 25%. Use this information to predict the approximate fish count in 2003. We are using our equation, y equals a times b to the x. What is the a representing? Initial population, and b is your factor. So we have y equals, what's our initial population? Okay, 1,200. Are we told what our factor is? No. But we are given the what? Okay, growth rate is 25%. 1.25 to the x. Now we're asked to find or predict the approximate fish count in 2003. So, when was the fish count first taken?
1995.
And we want to predict in 2003. So how many time periods?
8.
I'm sorry? 8. So what do we do with the 8? Okay. So y equals 1,200 times 1.25 to the 8 gives us what? And it's, what are we counting? Fish. Courtney invested $12,000 in an account that promised 12% annual growth. If the company's predictions are true, what would the value of the account be in 10 years? What is our initial investment? 12,000. Why 1.12? Very good. And to the power of 10. Very good.
37,270.
Any change? 18 cents? Okay. Every June, OSU civil engineering students have a concrete canoe race. The following table shows the relationship between each round of the tournament and the number of teams remaining. Determine the rate of change in the number of teams per round. How do I find the rate of change?
New minus old.
Okay, new minus old divided by old. So what is our newest population?
8.
Old population?
16.
Divided by? So 8 minus 16 gives me? Negative 8 over 16.
Negative 0.5.
Negative 0.5. What is that as a percent? Negative 50%. Write an equation of the form y equals a times b to the x. So y equals?
32 times negative. Oh no, negative 1.5. No, it's 0.5. Negative 1. It's negative 1.5. Just be 0.5. Yeah, it's negative 1.5. It's 1.5. You're adding 1. Yeah,
Just 0.5.
We're adding 1 to 0.5. Very nice. I'm sorry, we're adding 1 to negative 0.5.
Yeah.
So it will be 0.5
What I said.
to the x. Very good.
People don't listen.
Remember, the 1 is positive, and some of the growth rates are negative. So you're never going to have a negative factor here. Never. You might have something super, super small, but you're never going to have anything negative. So how many rounds are required to determine a winner?
5.
How do you know that?
Because you just charge divided by 2 and takes 5 rounds to get to 1.
Okay, so round 3, we would have how many teams left?
4.
4. Round 4, we would have,
2.
so that means round 5, we would have.
1.
How can we double check this with our equation?
Multiply the fifth power.
I'm sorry, say that again, Kels.
I don't know if that's right. Is it right?
I didn't hear what you said, but I think you are.
Multiply it to the fifth power.
Yep. So we can double check it by taking our equation, y equals 32 times 0.5, raise it to the 5th power. Tell me what you get. Thanks, Robert. So, 5 rounds give us a winner. If you deposit $200 into an account that pays 5% interest every month, how much money would you have at the end of the year? So let's write the equation. What's our initial investment?
$200.
1.05. And how much money would you have at the end of the year? How many time periods do we have?
12.
How do you know? 12 months in a year. So what do we have at the end of the year? Okay. If you buy a piece of art for $200 and it increases in value by 15% quarterly, which is 4 times during the year, how much is the art worth at the end of the year? So y equals, what's our initial?
200
Times
1.15
to the gives us
349.
C asks us to make a table for both investments comparing their values over the next 3 years. So for year 0, what's our money worth? 200. And for year 1, yes, we found it already up here, 359.17. So let's determine year 2. We have 200 times 1.05, and we're going to raise it to what power?
24.
Why 24?
2 years.
In 2 years is 24 months. Very good. So 200 times 1.05 to the 24th power gives us
645.02.
Okay. For the 3rd year, 200 times 1.05 to the 36 gives us
1,158.36.
All right, the artwork. What's the initial value for the artwork? 200. After year 1, what was its value? All right, year 2, 200 times y to the 8th power. Yes, quarterly, 2 years to the 8th power.
$11.80.
And for year 3, what's our equation?
200 times 1.15 to the
12th power. Good. And that gives us,
$70.05.
okay? All right, so if you were making this investment, consider the situation. Which is the better investment?
Money.
Why?
If we get more, we get money.
The value is higher. The money has a higher value. department has been monitoring the bear population in a wilderness area. Using a helicopter, they counted 20 bear in the area in 1992. The counts over the next 4 years revealed an average annual growth rate of 6%. If this rate of growth continues, what will the population be in 2008? What is my initial bear count? 20. Times what?
1.06.
Okay, we have a growth rate of 6%, so that gives us a factor of 1.06.
To the 16th power.
To the what power?
16th power.
Why 16?
Because that's the difference.
Between 1992 and 2008. How many?
50.
Okay. Example 6. Describe the pattern that exists in the following numbers. 2, 7, 24.5, 85.75, and so on.
Multiplying by 3.5.
How'd you find that?
I did 24.5 divided by 7.
You did 24.5 divided by 7? So if we do the new minus old divided by old, or just take 24.7 and divide it by 3. So if I do new minus old divided by old, I have 7 minus 2 divided by 2, which gives me 5 over 2, 2.5. What is this value right here? This is called the what? This value, 2.5, is the growth rate. Right? And what do we do to find the factor? Add 1. So our growth rate is 3.5, so our factor is, the growth rate is 2.5, so our factor is 3.5. And Jason took 24.5 and divided it by 7 and got 3.5. So we have a factor of 3.5. So how do we find the next number in the pattern?
Times it by
3.5. So 85.75 times 3.5 gives us?
300.1.
Very good. Questions?